All right, so this is the precise definition of a limit. So we already know our limit. The limit as x approaches a of f of x equals L. This is our standard limit we've been dealing with. So this is now our precise way of defining it. So if for every number epsilon greater than 0, there is a number delta greater than 0, and so that's epsilon, that's delta, such that, remember this is our absolute value now, so when we read it, we're saying such that if our x has a distance from a that is less than delta. So let's figure that one out first, and so we know what it means. So we're saying our x has a distance from a that is less than our delta, right? So we're just using those variables. So our x has a distance from a that is less than delta. So looking at that as an inequality, we go to our x-axis. That's a. And that means we're going to have some delta units this way and some delta units this way. So we're going to subtract delta. And let me erase that so I have more room. And a plus delta, just like before. So if we had a 3 and a 5, we would add 5, subtract 5. So we're going to add delta, subtract delta. And so that is our interval from the first one. Now let's look at the second one. We'll do that one in red. So now it says that our f of x has a distance from L that is less than epsilon. So our f of x has a distance from L that is less than epsilon. So think about some function sitting here. If we have some function coming up here, right? And if you follow a up, that is our limit L over here. We'll put that in red to match L. And so what we're saying is our f of x, those y values that we can have here for each of these given x values. So we can plug in an x value here that's delta units away, and it will give us a matching y value. And those y values have to have a distance from L that is less than epsilon. So we're going to come up here, and if you trace this green line up and then over, we're basically saying, right, that we have some L minus epsilon, right? And this is not exactly right. I'm just trying to give you the idea here because we're going to do a little work with this L plus epsilon. But that we are some epsilon units away, that if you add delta and subtract delta, we're within that limit. And it's just our basic definition that as we approach a, our x, we should be approaching L, right? So if we're some distance away delta here, we should be some distance epsilon away. So here's some stuff here to remember what we're doing. But basically what we're saying, as x gets closer to a, f of x gets closer to L. Our epsilon here is our distance. Our y value is from L. Our delta is our distance that we have from a. So x minus a is delta and f of x to L. All right, so let's try one. So we have the limit here. No more variables. Well, we're going to use epsilon delta, but just plain old this guy. Okay, so we have the limit as x approaches 3 of 2x equals 6. So let's start with each of these. And they're very quick to decipher. This is just 2x minus 6. That's the absolute value. So we're taking the y values and subtracting them. Our 2x has a distance from 6 that has to be less than epsilon. And then the bottom one, that's our delta. So if you look at it, it's just x minus 3 is less than delta. And that's where I get these from. So we have x minus 3 is less than delta, and then 2x minus 6 is less than, oh, where did that come from? So if you read it, it says, suppose we want our 2 of x to be within 0.1 units of 6. So what we're saying is that our 2x has to be 0.01 from 6. So our 2x has a distance from 6 that is less than 0.01. So what they're doing is they're giving you, should be in blue, they're giving you the epsilon. So we can already go on here and say, okay, well, that's 6. And we're saying our y values have a distance from 6 that is less than epsilon. So it's this right here. So we're taking our 6 and you're adding that epsilon. So we're going to add 0.01 and you're going to subtract 0.01, giving us the 5.99. So when you read this 2x minus 6, right, our 2x has to have a distance from 6 that is less than some epsilon, and that epsilon is given. So now what they're asking is how far from 3 should we choose the x? This is right here is the question saying, what's delta? We don't know what delta is. That's not it. It's an 8. What's delta? So if you look at our function, y equals 2x, we can draw that. That's a line. If you trace this back, you'll see that that is 3, because the limit, remember this is a polynomial and it's continuous, so we can just use the substitution property where we plug it in. So 2 times 3 is 6, so 3 is 6, it's continuous, everything's perfect, right? And so if you trace these back, these will give us our possible deltas. That's what we're looking for. So if you read this up here, what we're saying is that if x minus a is less than delta, then our f of x minus L has to be less than epsilon. So we're trying to find some delta here that will give us an epsilon of 0.01, a distance from 6 of 0.01. That's all it means. So we plug it back in. So these are your y values. That's y1. That's y2. So if we have y equals 2x, then we plug in 6.01 equals 2x, and then divide by 2, and divide by 2, and you plug that in your calculator. We get 3.005, and then we use the other one, which is 5.99 equals 2x, divide by 2, divide by 2, and I'm going to call that x sub 1, and that's x sub 2. Okay, so if we plug those into your calculator, you get 3.05 and 2.995. So what we know then is our x sub 1, this guy is 3.005, and this is 2.995. And so what we're asking again is how far from 3 should we choose our x? So we already now know how far we are from 3 to get these distances. So to have a 0.01 amount of error here, right, our epsilon's 0.01, then the corresponding x values would be 3.005. So if I were to plug 3.005 into 2x, I would get 5.99. And if I plug 2.995 into 2x, I would get 6.001. So now if I plug them in over here into our absolute value, and so we just plug in our x's, 3.005 minus 3, and I plug in 2.995 minus 3. Plug those in your calculator, so all I have to do is go back up, grab it, and subtract 3. We get 0.005. Same thing. We get 0.005. So 0.005, 0.005. That's your delta. So your delta here is 0.005. So how far from 3 should we choose the x? 0.005. And that's the units here. So remember, the delta is just how much do we add here? Delta minus delta to make it work. Okay, I want to show you this in Desmos to give you an idea of what's going on as well. So what I have here is an x squared, and our x star is 2. So right there, that's our a, and that's our L. And so you can see here that I have some epsilon here difference. So my epsilon here, what is that? We'll just say that's an epsilon, equals 2. And over here it's also 2. So I'm adding 2 up and I'm subtracting 2 down. And so now all you have to do is find those corresponding values down here. Now this is an x squared, so it's a little different than the line. So if you notice when I plug it in right here, it's going red, and the reason is because it's outside. So if I use a delta of 0.5, it's actually taking me too far. So when you do this, you're going to get a number that comes down here and a number that comes down here, one that is larger and one that is smaller distance, right? And so what you have to do is always pick the smaller of the two. If I try to make this one go all the way out to the biggest difference, look at that. It's a little finicky. There we go. So you can see that is my biggest delta here, but look, this side went outside. So if I use that to find my epsilon's going to be a lot bigger than 2. So if I want my epsilon to be 2, I can't use this delta. So what I have to do is always pick the smaller distance of the 2. You got to always make sure your delta, both of them, right, that delta that you pick will give you an epsilon that you need. So it's always the smaller of the 2. So we'll talk about that in the next video. So this is something you're going to have to sit there and really digest, because it's not as simple as it looks, but if you do a few of them, you'll start to get the hang of it and you figure it won't be too bad. So again, the delta here is just the distance from the number you're approaching for x. The epsilon is just the distance from the number that you're approaching, your limit. So as we approach 3, right, we're going to have some delta that has a distance from there. And as you approach 6, you're going to have some epsilon from there. All right, so if we have x minus 3 is less than delta, let's say that epsilon over 2, this would give us this, which states that x has a distance from 3 that is less than epsilon over 2. And then now if I multiply that 2 in, we get 2x minus 6 is less than epsilon, right? Which now says that our 2x has a distance from 6 that is less than epsilon, and that's what you're trying to prove. So what we're saying here is that if we have some value delta that's greater than 0, right, then our x has a distance from 3 that is less than that. So we have picked epsilon greater than, we have put epsilon over 2 to be our delta, both of which are now greater than 0, so it satisfies it. And then by doing a little manipulation, we have shown that this is true. So because this is true, this is true. So that's your if statement and then. So if this is true, then this is true. So our limit is true. All right. Thank you.